Assalamualaikum warahmatullahi wabarakatuh. My name is Amir Faris bin Muhammad Solong. I'll be explaining about how to read the psychrometric chart. First and foremost, we need to know about the elements that are present in the psychrometric chart. Firstly, the bottom axis indicates the dry bulb temperature, and it does not involve any kind of moisture. On the right axis, on the other hand, it indicates the humidity ratio, or also known as grain. The humidity ratio indicates the amount of moisture that are present in a pound of dry air. The outside curve is known as the saturation curve, where it indicates the maximum amount of moisture that can be held by 1 pound of air. If anything get past the saturation curve, it will condensate and turn into water. And lastly, the inner curve and the diagonal lines. The inner curve of the psychrometric charts indicates the relative humidity percentage, where the humidity is relative to the current temperature. The diagonal lines inside the curve indicates the wet bulb temperature, and the diagonal lines outside of the curve, where it looks like a ruler, indicates the enthalpy. Next is how to read the psychrometric chart. This includes 3 steps. First is how to find the dew point temperature, and how to find the relative humidity, and lastly, to find the wet bulb temperature and the enthalpy. For step 1, we need to plot the given dry bulb temperature and specific humidity, for example 75 degrees Fahrenheit and 60 grain. We need to plot the line and pull the line from the specific humidity until it touches the saturation curve, and pull the line from 75 degrees Fahrenheit until it touches the line from the saturation curve, and the point at the saturation curve is the dew point temperature. Next, from the dry bulb temperature, which is 75 degrees Celsius, degrees Fahrenheit, sorry. Next, from the dry bulb temperature, which is 75 degrees Fahrenheit, we need to pull the line up until it touches the saturation curve, and then pull the line to the right to obtain the maximum amount of moisture that 75 degrees Fahrenheit can hold, which is 132 grain. To find the relative humidity, it is calculated by dividing the given grain with the maximum grain, and then times it with 100, and it will get 45%. To get the wet bulb temperature, we use the diagonal line inside the psychrometric chart as a guide. We need to draw a parallel line that runs through the intersection between the grain and the temperature that is given until it touches the saturation curve. The temperature at the saturation curve is the wet bulb temperature, and pull until it reaches the diagonal lines that looks like a ruler, and that is the enthalpy value. As an additional note, the dry bulb temperature is the temperature on the bottom axis, as it already indicate, and the specific humidity is the grain on the right axis.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Fauzan Shafi bin Muhammad Fodi, and I will proceed with the part 2 of our group video. So this is the problem that we got, which is the atmospheric air at the dry bulb temperature of 21 degrees Celsius and 30% relative humidity passes through the humidifier in such a way that final dry bulb temperature is 36 degrees Celsius and 50% relative humidity. So we need to find the heat added to the air, the moisture added to the air, and the sensible heat factor of the process. So in this problem, we will use the degree Celsius. So first of all, we need to list all the information that given from the question, which is the initial dry bulb temperature and the final dry bulb temperature. Next, point the information into the psychrometric chart, which at the 21st degree Celsius and also at the 30 to 36 degrees Celsius. So for the heat added to the air, first we will make the oblique line in the intersection of the temperature and the relative humidity. So for the initial dry temperature, for the for the heat for the enthalpy, we get the value of 33.5 kilojoule per kilogram. Then the final and the enthalpy reading for the final temperature is 84 kilojoule per kilogram. We will label it label it with H1 and H2. So the formula is H2 minus H1. So the heat added equals to H2 minus H1. We will get the final answer of 50.5 kilojoule per kilogram. So next, we want to find out the moisture added to the air, which we will label as the W1 and W2. Both of the both of the value we can get at the psychrometric chart. So at the intersection of T1 and 30% relative humidity, we will make a horizontal line until it touch the humidity ratio, which we label as W1. The next value is the intersection of T2 and 50% of relative humidity. Also, we will make a horizontal line and label it as the W2. So for the final answer, we should have the answer in kilogram per kilogram, but the graph is in gram per kilogram. So both value we will need divide by 1000 kilogram. So W1 is 0.00495 kilogram per kilogram and W2 is 0.019 kilogram per kilogram. We will use the formation for we will use the equation of W2 minus W1, and the final answer should be 0.01405 kilogram per kilogram. And lastly, we need to find the sensible heat factor of the process. So using the formula of sensible heat per total heat, we can get the sensible heat factor. And the total heat is the sum of the sensible heat plus the latent heat. First of all, we need to calculate the enthalpy of the H3. So if we look at the chart, I've already labeled A as the intersection of both final and the initial temperature. We will do the same as the heat added. We need to find the enthalpy of the A. So make a oblique line to the enthalpy till touch the enthalpy region, and we will get the value of 48 kilojoule per kilogram and label it as H3. So using the formula of H3 minus H1 it divided by H2 minus H1. So we will sub we will sub the value, and the final answer should be 0.287.